Hold still for a second and think about what is inside your own bones. Calcium, mostly. But mixed into them, right now, there is lead, a heavy metal that does nothing good in a human body, sitting in the skeleton of every single person watching this. And here is the part that should stop you. You are carrying hundreds of times more of it than any human who lived before about 100 years ago. Not a little more, hundreds of times. For almost all of human history, people walked around with bones that were nearly clean, and then, in the span of a few decades, we filled ourselves with a poison and barely noticed. One man noticed. He was not a doctor, and he was not trying to save anyone. He was a geochemist trying to do something that sounds completely unrelated, to weigh a meteorite and work out how old the Earth is. And in the process, almost by accident, he uncovered the fact that the entire planet, the air, the oceans, the ice, and your blood, had been quietly poisoned. Then he spent the rest of his life fighting the industry responsible, and it very nearly buried him. Not in a grave, but professionally. They tried to starve him out, and the reason there is far less lead in your body tonight than there should be is that he refused to back down. His name was Clair Patterson. Almost no one outside of geology has ever heard it, and that is the quiet injustice running underneath this whole story. Because two of the most basic facts about the world you live in came from this one stubborn man. The first is the age of the Earth itself. If you have ever heard that our planet is about 4.5 billion years old, you are quoting him. He is the person who finally pinned that number down. And the second is darker. He is the one who proved that the modern world had soaked itself in lead, and who then forced it back out. Think about that pairing for a moment. The age of the ground under your feet, and the poison in the blood inside you, both nailed down by the same person, and you have probably never said his name out loud. So here's where we are going. I want to show you how you weigh a planet you can never touch, because the trick is genuinely beautiful, and you can follow every step. Then I want to show you how chasing that one measurement led him to a horror nobody else had seen, and how he took on the most powerful industry in the world and won. Clair Patterson was born in 1922, a small-town kid from Iowa, the kind who took apart anything with a screw in it. He was sharp, he was stubborn, and he fell in love with chemistry early, the way you might remember one subject quietly taking over your whole head. He went to a small college called Grinnell, and then, while he was still barely out of his early 20s, the Second World War swept him up into the most secret project on Earth, the Manhattan Project. They put him to work at Oak Ridge, Tennessee, on the problem of separating uranium using a machine called a mass spectrometer. Now hold on to what that machine actually does, because it is the key to everything that follows. A mass spectrometer sorts atoms by their weight. You feed it a sample, and it can tell you exactly which kinds of atoms are in there, and how many of each, down to staggering precision. Patterson became a master of it. He learned how to count specific atoms by weight better than almost anyone alive. He went into the war helping to build a bomb. He came out with a skill that he would aim, of all things, at a rock from space. After the war, Patterson went to the University of Chicago for his doctorate, and there a mentor named Harrison Brown handed him a question that sounds like something a curious child would ask at dinner. How old is the Earth? People had been guessing for centuries, and the guesses were all over the map, from a few thousand years to a vague many millions. Brown thought Patterson's atom counting skill could finally settle it. But there is a cruel catch buried in the question, and you need to feel it to understand why this was so hard. You cannot just pick up a rock from the ground and date the planet, because the Earth is alive. Its surface is constantly churning, melting, burying, and remaking itself. Mountains erode, ocean floors slide back into the deep, and the oldest original rock is long gone, recycled away. The planet is a clock that keeps wiping its own face clean. So how do you measure the age of something that destroys the evidence of its own birth? That was the wall Patterson walked up to, and the way around it was to stop looking at the Earth at all. Here is the tool that makes it possible, and it is one of the most elegant ideas in science. Certain heavy atoms are unstable. Uranium, given enough time, slowly falls apart and turns into lead, atom by atom, at a rate that never changes. It is a clock you cannot speed up, slow down, or reset. Seal some uranium inside a fresh rock, come back later, and by measuring how much has turned to lead, you can read off exactly how much time has passed. And here is the detail that makes it bulletproof. There are two different kinds of uranium decaying at the same time, into two different kinds of lead, and they run at very different speeds. One is slow, one is fast. So you do not even have to measure the uranium at all. Just the ratio between the two kinds of lead tells you the age, all by itself. Picture two hourglasses started at the same instant, one that empties in minutes and one that takes hours. Even with no clock on the wall, A glance at how much sand is left in each tells you how long they have been running. That ratio was the clock Patterson knew how to read, because reading atoms by weight was exactly the skill the war had given him. But he still had the original problem. Earth's own rocks were too scrambled to use, so Patterson made the leap that solved it. If the Earth has erased its own beginning, find something that has not. And there is something: meteorites. Most of them are leftover rubble from the exact moment the solar system formed, chunks that have been drifting, cold and untouched, for 4.5 billion years, frozen at the instant of their birth. Date a meteorite, and you are dating the raw material the Earth itself was built from. Patterson got his hands on a piece of the Canyon Diablo meteorite, the very object that smashed out Meteor Crater in Arizona, and he used it to lock down the starting point of the clock. Then he measured, with the obsessive precision he had learned counting uranium, and in 1956, he had his answer: 4.55 billion years. Now let me be careful and fair, because this is where the story is often told wrong. Patterson did not invent the idea that the Earth was ancient. Others, like Arthur Holmes, had argued for billions of years before him, and he did this work alongside colleagues like Harrison Brown and George Tilton. What Patterson did was nail it. He turned a centuries-old argument into one hard, precise number, and that number has barely moved in 70 years. The age of your planet settled by counting lead in a rock from space. Now the story turns, and it turns on a problem that would have made most scientists quietly give up. To date those rocks, Patterson had to measure lead at almost unimaginably tiny levels, and when he did, the numbers came back wrong. Wildly, impossibly wrong. There was far too much lead in his samples, more than the rocks could possibly contain, and it showed up everywhere, in sample after sample, even in the blanks that should have had almost none. Think about what you would assume in his place. You would assume you made a mistake, that the sample was bad, and you would move on. Patterson did something harder. He took the contamination seriously, and he asked where it was coming from, and the answer, when it finally clicked, was staggering. The lead was not in the rocks. It was in the room. It was in the air, in the dust on the bench, in the glass of his equipment, in the chemicals he was using, on his own hands and breath. The modern world itself was so saturated with lead that it was leaking into his experiment from every direction at once. He could not measure the lead in his rocks, because everything around him was already drenched in it. So Patterson did something nobody had really done before. To measure lead, he first had to get rid of all of it, so he built one of the world's first truly clean laboratories. Filtered air, every surface scrubbed and acid washed. Chemicals purified over and over, all to drive the lead out of the room so he could finally see the tiny natural amount in his samples. And it worked. But when he finally cleared away all that contamination and could see the true natural level of lead for the first time, what he found stopped being about meteorites entirely. The amount of lead in the modern world was not a little above natural. It was hundreds of times above it. And here is the thought that must have kept him up at night. If his lab in California was this drenched, it was not just his lab. The contamination was not local. It was everywhere, on a scale that could only mean one thing. The entire planet had been flooded with lead, recently and fast. He had gone looking for the age of the Earth, and stumbled onto the poisoning of it. So how do you prove something that big? You cannot sample the whole world. But you can do something clever. You can compare the present to the past, by going where the past is still preserved. Start with the oceans. Patterson and his colleagues measured the lead in surface seawater, then compared it to the deep water far below, water that had been down there, sealed away from the modern air. For a very long time, the surface was loaded with lead. The deep, older water was far cleaner. Then he went further to the ice. In Greenland, snow falls and never melts, so it stacks up year after year, century after century, trapping a frozen record of the sky. Drill down through that ice, and you are drilling back through time. Patterson read it like a ruler. The ancient deep ice held only a trace of lead. The fresh snow at the top held over 100 times more. Everywhere he looked, the same pattern. The deeper into the past he went, the cleaner the world got. The lead was recent, it was global, and it was raining down out of the sky. All he had to do now was find out what had started falling. The answer was sitting in almost every vehicle on Earth. In the 1920s, the car industry started adding a lead compound to gasoline to stop engines from knocking. It was cheap, it worked, and from that point on, every car, truck, and bus burned lead and blew it out the tailpipe as a fine dust. Billions of engines, year after year, seeding the entire atmosphere. That is the spike Patterson had found in the ice. That is the lead in the ocean. And that is the lead in you. Because here is where this stops being about ice cores and lands in your own body. Compare the bones of a person alive today with the bones of someone who lived before all this began, and the modern skeleton holds somewhere between 700 and over 1,000 times more lead. This is not a metaphor, and it is not an exaggeration. It is what the measurements actually show. Lead is a neurotoxin. It is especially cruel to children, whose growing brains have no safe level of it at all. An entire planet, including the person watching this, had been dosed with a poison for the sake of a smoother engine. And one geochemist with a clean lab was for a while almost the only person who could prove it. Now you might think that proving the whole planet was poisoned would make Patterson a hero overnight. It did the opposite, because the industry that made the lead had spent decades building its own science and its own expert. His name was Robert Cahoe, and he ran a laboratory funded by the very companies that profited from leaded gasoline. Cahoe's argument was clever, and you have heard versions of it ever since. He said lead was natural, that humans had always had some in their bodies, and that until you could prove a specific, measurable harm, there was no reason to act. "Show me the data," he said. The burden was on the critic to prove danger, not on the industry to prove safety, and for decades, that single framing kept lead pumping into the air unchallenged. This is exactly the wall Patterson's work knocked down, because Cahoe's whole case rested on the idea that modern lead levels were normal and natural, and Patterson had just proven, atom by atom, that they were nothing of the kind. The so-called natural baseline was a fiction. The real natural level was hundreds of times lower. He had not just measured a poison, he had demolished the industry's entire defense. So the industry came after him, not with arguments, but with pressure. After Patterson published his findings, the petroleum industry pulled the funding it had been giving him, around $200,000, gone. A government health contract he relied on quietly dried up. According to people close to it, an oil executive who sat on the board of his own university leaned on the president to make him stop. And in 1971, when the nation assembled a panel of experts to study lead in the air, they left the single most knowledgeable person in the country off the list. Picture that. The man who had measured the problem more precisely than anyone alive, frozen out of the room where the decision would be made. No threats, no drama, nothing you could point to in a headline, just money cut off, and doors quietly closed. The slow professional starving of an inconvenient scientist. You have probably watched a smaller version of this happen to someone who told a truth that cost powerful people money. That is what they did to Patterson, and he just kept publishing anyway. Here is the thing about being right when your evidence is this solid. You can be ignored, defunded and shut out, and still, slowly, win. Patterson kept testifying. When a committee tried to water down its conclusions, he fired back with a 78-page report refusing to soften the truth. And year by year, the science became impossible to deny. Through the 1970s and 80s, lead was forced out of gasoline, pushed out by new laws and a public that had finally heard the warning. And then came the proof you cannot argue with. As the lead came out of the fuel, scientists tracked the lead in Americans' blood, and it fell off a cliff. Average blood lead levels dropped by nearly 80%, falling almost in perfect step with the lead disappearing from gasoline. He had said the source was the fuel, removed the fuel, and the poison drained out of an entire population, exactly as he predicted. There is no clearer way to be proven right than to watch a whole country get measurably healthier because you would not shut up. Let me be honest about the size of the claim, because he deserves accuracy more than hype. Clair Patterson did not do this alone, and he did not ban lead with his own hands. It took new laws, government agencies, other researchers studying lead in children, and years of public pressure to finish the job. What Patterson did was light the fuse. He was the one who proved the baseline, who showed the world that normal was a lie, and who would not let the question be buried no matter what it cost him. For all of it, the recognition came late and quiet. He finally received a major environmental prize in 1995, the same year he died. No Nobel, no fame, no household name. He changed the chemistry of an entire planet, and odds are you had never heard of him until tonight. So, pull all the way back with me. 2 gifts. From one stubborn man who refused to take the easy answer. Look down at the ground beneath your feet. It is about 4.5 billion years old, and Clair Patterson is the reason you can say that with confidence. Now look at the back of your own hand. There is still lead in you. In your blood and your bones, there always will be. But there is far, far less of it than there would have been, because one geochemist chasing a rock from space noticed something was wrong, and then spent his life refusing to be quiet about it. He did not cure lead, and he did not win alone. But the cleaner blood moving through you right now traces straight back to him. That is the real shape of this story. You live every day inside his 2 numbers. the age of your world, and the poison taken back out of your body, and almost no one can tell you who he was. Now you can. His name was Clair Patterson. If Clair's story got under your skin, do me a small favor. Like this video, subscribe to follow the rest of these, and tell me in the comments whose forgotten story I should draw next. There are so many of them still waiting for someone to finally know their name.